Graphs of other trig functions. You should be familiar with unit circle values of sine and cosine. In this lesson, we will draw graphs of y equals tangent of x, y equals cotangent of x, y equals secant of x, and y equals cosecant of x. We have seen how to graph y equals sine of x and y equals cosine of x. We will now graph the tangent, cotangent, secant, and cosecant functions. We will begin with y equals tangent of x. Recall that tangent is sine divided by cosine, and that the cosine of x is 0 at negative pi over 2 and pi over 2. At pi over 2, the sine is 1 and the cosine is 0, and 1 divided by 0 is undefined. Tangent is also undefined at negative pi over 2. We will discuss what is happening close to these values later. For now, we will mark those two x values with dotted lines for asymptotes and draw the graph in between. Sine of 0 equals 0 and cosine of 0 equals 1, so the tangent of 0 is 0 over 1, which is 0. So we'll place a point at 0, 0. The sine and cosine of pi over 4 are both the square root of 2 over 2, and when you divide square root of 2 over 2 by itself, the answer is 1. So we'll place a point at pi over 4, comma, 1. At negative pi over 4, we get the same result, except that the sine value is negative, while the cosine value remains positive, and therefore the tangent of negative pi over 4 is negative 1. Now, back to what is happening near pi over 2 and negative pi over 2. When we have an angle that is just a little smaller than pi over 2, the sine value is almost 1, and the cosine value is almost 0, but both are positive. When we divide, the answer is very large. The graph approaches an asymptote at pi over 2, growing very large and positive, so the graph is going up to infinity. The same thing happens at negative pi over 2, except when we take angles slightly to the right of negative pi over 2, we are dealing with angles in the fourth quadrant, so the sine is negative while the cosine is positive. When we divide, the answer is large and negative, so we are going down to negative infinity. One branch of the tangent wave looks like this. What does the tangent function look like to the right of pi over 2? Take a moment to calculate the values of tangent for the angles 3 pi over 4, pi, and 5 pi over 4. You may wish to pause here to calculate those values. The tangent values at 3 pi over 4, pi, and 5 pi over 4 repeat the same pattern as before, namely the values are negative 1, 0, and 1 respectively. Thus the branch of the tangent function between pi over 2 and 3 pi over 2 is identical to the branch from negative pi over 2 to pi over 2. Since the unit circle repeats every 2 pi, so does the graph of tangent, and we get a repeating sequence of these branches. Graphing y equals cotangent of x is similar. Recall that cotangent is cosine divided by sine, so that the cotangent is undefined when sine of x equals 0, which is at 0 and pi. At pi over 2, cosine divided by sine is 0 divided by 1, which is 0. At pi over 4, the cotangent is 1, and at 3 pi over 4, the cotangent is negative 1. The cotangent graph is headed downward toward pi and repeats every pi just like the tangent did. Cosecant is the reciprocal of sine, so we will use the sine wave to help us graph the cosecant function. The cosecant will be undefined where the sine is 0, which is at 0, pi, and 2 pi. At pi over 2, the reciprocal of 1 is 1, and similarly, at 3 pi over 2, the reciprocal of negative 1 is negative 1, so we can plot those 2 points. At pi over 6, the sine is 1/2, so the cosecant is 2. The same is true at 5 pi over 6. The sine is negative 1/2 at 7 pi over 6 and 11 pi over 6, so the cosecant is -2 at those inputs. We can then sketch the cosecant graph from 0 to 2 pi. Since the sine graph repeats every 2 pi, so does the cosecant graph. The process for secant is similar. You may wish to try it on your own before watching the end of this video. We will start with the cosine wave. Place asymptotes where the cosine is 0. Place the values 1 and -1, and the values plus or minus 2 at the pi/6 markings. Sketch the graph from 0 to 2 pi, and repeat every 2 pi.